All right, how's it going? I've been sitting in this room drinking coffee for the last 45 minutes, so this is going to be interesting. So the title of this talk is Puppet in the Trenches. My name is Paul Hinze. I'm on the infrastructure team at Braintree. So I'm going to tell you what all of that stuff means. The reason I chose this term Guerrilla DevOps is basically is the same as the reason that I'm really excited to be at PuppetConf. This is my first PuppetConf after having used Puppet for like 3 years now. And that reason is I don't know what I'm doing. And I'm hoping there are people here who might know. So can I get just a quick show of hands? Who knows what they're doing? Anybody? Oh yes. Okay. Okay. Subset of that. Anybody know what I'm doing? That would be most helpful to me. Come and talk to me afterwards. That's sort of what this talk is about. It's about the story of our infrastructure and our management of their infrastructure. Basically, the story of going from not knowing what the hell you're doing to not knowing what the crap you're doing. So we're making progress, right? It's kind of a linear, decreasing expletives. So today I'm going to talk about why we chose who Braintree is. So if you don't know, you will know why our managing our infrastructure is interesting. I'm going to talk about some of the why we chose Puppet, some of the an open source tool that we use to manage the way that we use Puppet. It's called Supply Drop, and I'm going to tell you about some of the terrible ways that we've screwed up and lessons we've learned along the way. So let's do this. Okay, so who is Braintree? When I'd like to talk about what Braintree does, I'd like to talk about the two scariest things for software developers in the world. So what I mean by that is if you were to tell a software developer, please develop software that does this, they would crap their pants. Number one, keep people alive. If you tell a software developer, I would like you to write software that is responsible for keeping people alive, scariest thing in the world. In my book, number two is getting people paid. I have a lot of respect for the people who do number one, but number two is where we work. And so that's sort of the point of Braintree is to take some of the scariness out of getting people paid. Basically, we want to make it dead simple to do payments, right? Because, so we work with all of these awesome businesses, people like GitHub, 37 Signals, Living Social. They want to do their core business, whatever their core business is, they don't want to have to worry about payments. So that's pretty much what Braintree does. So that's a conceptual level. Let me show you a specific level. It's best to just show it with an example. So let's say you, in your unending wisdom, have decided to purchase a Angry Bird with the Santa hat on it because it's September, and that's seasonally appropriate. Rovio is the company that makes Angry Birds. So you're probably on Rovio's website. You're going to put your credit card in to purchase that thing. You're not actually giving your credit card to them. You're giving your credit card to us securely. And what we do is we communicate with the banks to actually make the charge, and we also securely store that credit card. So at base, what we do is clean APIs up top. We have nice client libraries to make payments super simple. And then we have all these bank integrations, and we have secure storage of credit cards. The bank integrations are a trip. We have a ton of them, and they are all flavors and shapes and sizes. My personal favorite is the one that says, just open a TCP socket to us over the internet. That's your integration? Yes, just push bytes over this TCP socket. Okay, calculate our own checksum bits? Yes, okay. So talk to me later. There's a lot of fun stories about integrating with like crazy old-ass back-end banks. But that's sort of why our company exists, right? Is we provide nice, clean APIs on top of this craziness underneath. Basically, Braintree's idea is in the payment space, we want to provide modern tech. We pride ourselves on killer support. If you call us, you get a human being. And most importantly for today, a rock-solid platform. The whole point of having somebody else do your payments is you don't have to worry about it. And it doesn't matter how easy it is if it's just going to go down. We need to be the most solid part of everybody's infrastructure because we're the part actually making the money. Okay, so why do we use Puppet to manage our infrastructure? To tell you that story, I have to tell you about the history of Braintree a little bit. So we started out as a small startup. We're no longer a small startup. We're just an up now. And so when we started, though, we just had a small team of like about 5 guys, burgers and fries. We were basically tasked with this huge task of building software that's going to process billions of dollars in payments. So two things that make that hard. One is security. The whole point of what we're doing is that it has to be incredibly secure. It has to be trusted by all of these major people that we really want to please. And then two, it has to be high availability is crucial, like I said, right? If we go down, not only are we down, right, we're actually ruining the ability of all of our merchants to do business. So that's like a higher order failure. It's like an integral failure case. So that sucks, right? So security and availability are of utmost importance in our environment. So when you're a small startup, you sort of use the things that you have. What we had was a small team of purportedly badass developers coming from the applications development space. So we thought we were badasses, Ruby badasses. So that means we're into like test-driven development, domain-driven design, agile software, Git, Jenkins, Ruby. We all had experience delivering software. So we felt pretty good about the application layer in terms of building this platform that we knew was going to process all of this money, right? And we're purportedly full stack developers. We like to believe that we value at least understanding the entire stack that we're standing on. However, we did not have a lot of experience in server administration. So it's a small team, right? So you just have to do it. You have to figure it out. So that required a lot of research and a lot of slow going. And what we came upon was Puppet. So why we like Puppet as a group of badass Ruby developers, quote unquote badass Ruby developers, is automated consistency. So coming from TDD, we really like things that are verifiable, repeatable actions, and that's exactly what Puppet does. You can version control the manifests, so that we can kind of dovetail it in right to our Git infrastructure, and most importantly, it provides you the ability to create layers of abstractions in your infrastructure. You tell a developer, I'm giving you a tool to create layers of abstraction. They're just like sold already. So that's I think the core benefit of Puppet is this ability to factor up all of the things like files and packages into concepts and then layer those concepts into even bigger concepts. So Puppet it is. So we actually use masterless Puppet, which is a non-standard deployment of the Puppet system. So I'm going to just quickly describe what that is for you. So here's your standard setup. You've got a Puppet master server in your environment, and then you have a Puppet agent running on each of these, each of your servers. It's just a daemon running on each of your servers. It's going to check in with the Puppet master. The Puppet master is going to respond with specifically what that server needs to do. So what masterless Puppet does is flips it on its head. There is no daemon running on the servers. You just have developers pushing changes out via a simple execution of Puppet apply. And then what we do is we use the central repository managed by Git. So we're actually pushing code out and then simply invoking Puppet apply, and when you're done, there's nothing running on the box. So there's a couple of reasons that we want to do this. One is fine-grained control. You combine the fact that we had a very high stakes in a production environment with the fact that we knew that we did not have tens of years of experience managing servers. We want to be super careful whenever we're interacting with anything in production. So this fine-grained control you'll see when I show you the tool. It allows us to target single servers, it allows us to target classes of servers, and allows us to target whole environments. But it allows us to look at the changes just before they're made and be present just after they're made. Rather than a Puppet master scenario where you're pushing the changes to the Puppet master, they sort of eventually get out to the boxes, we want it to be there exactly when the changes were being made. Parallelization, so kind of the other end of that spectrum in a QA environment, the Puppet master model is very much like Subversion in that you sort of have to be in lockstep with this central point of truth in your environment. And with the masterless scenario, you can actually just push out changes. So I'll show you an example where we have two people working in different parts of the environment and using Git to interact with each other. Yeah.
So isn't Git your single point of failure?
I'll talk about that a little bit. Yes, you could argue that Git is our single point of failure, but sort of the nature of Git is a bunch of copies, and with a combination of backups, I think you could be okay. But yes, you could argue that. Yeah, so you were jumping down to that one, which is it's distributed. There's no single point of failure. There's no basically what I mean there is that we don't have another piece of our infrastructure that we have to manage, as in the Puppet master, something we have to HA and back up and all that stuff. Okay, so I'm going to talk about supply drop. Supply drop is a very small tool that we wrote to help us do this. It is super simple, and the best way to show you it is just to show you an example of using it. So here I'm just going to pull it down. So I'm going to make an infrastructure directory, and then I'm just going to gem install supply drop. It's a Ruby gem, and it also it relies on capistrano to do its remote command execution. So I'm going to initialize the capistrano environment, which basically just sticks out this base config. So that's how you need to get it. There's one more piece that we need here in the config deploy. So this is the entirety of the config deploy that you need. So it's going to be a total of like 15 lines. So we're just going to require the library, and then this tasks for data center is a simplification of something that we do. It looks kind of hairy, but it's pretty straightforward. It just takes 2 arguments, the name of a data center and a list of servers, and then it's going to make one task for all the servers. So the task with its data center title is going to target all the servers, and then there's one individual task for each of the servers. So in Capistrano, when you say role server, when you put something into a role, that means Puppet is going to target it. You'll see how this, well, first of all, so this is sort of like a macro that then you use to define your data centers. So let's say we have two data centers or 2 locations that a QA in production, each with an app box and a DB box, right? And let's start ourselves out with a very simple Puppet manifest. So we're just going to install Python on the app box, just in QA. So this isn't really very realistic, but this is how it's used. So from any box that has SSH access to these nodes, you can run cap, box name, and then Puppet nuke. You're going to see the nuke out right there. And then you can run cap, box name, Puppet apply. It's going to apply it. Very straightforward. So again, this is the way that we apply all changes to all of our environments. So essentially what supply drop is a set of Capistrano tasks, some parallel rsync to push the local Puppet manifests over the wire, and then some basic collision detection to as we're working in an environment, make sure no 2 people are attempting to work in the same box. So now I'm going to go over sort of each of the values that we wanted to get out of masterless Puppet and show you those kind of in action. So this gives us the fine-grained control that we want for taking actions in production. You can see we can target a single box to look at a nuke. We can use simple bash expansion to target multiple boxes, or we can target a whole environment. So you'll see kind of like the actual practice that we have around that in a second. And then we map Git branches to our environments. So this allows us to have explicit environment promotion of any changes that we're having. So we have master maps to QA, staging maps to our pre-prod environments, and production maps to, you can guess, production. And you'll see that in our practices, we always look at the diff before doing anything. I'll have a nice example of that in a second. So parallelization. So we basically have a story here that basically happens on a daily basis on our infrastructure team. We'll have 2 people working in the QA environment, and somebody's working on non-US checks, somebody's working on tweaking database configs. They can both interact with their individual servers and then simply use Git to interact. As long as they're pulling before they commit, everybody can work simultaneously. So we really like that. And then we sort of make it a policy to go for what we call a clean nuke at the end of the day. So somebody's running for an entire environment, making sure all of the nuke is empty when you're done with a given day. Okay, so here's a big example of the way we actually do things. So there's a lot here, but it's just sort of step by step. This is going to be a merge from master to staging. So we're just going to run a git merge, and the first thing we do is we review the log, and then we review the diff. So we're looking at the diff in the Puppet manifest to see what changed. Then we're going to run the nuke across the entire environment to get that big long nuke of all the changes that's going to be part of this merge. Then what we do is we can pull out specific boxes from that nuke that we consider to be higher risk changes. So let's say we're changing the database config, we know that's going to run a Postgres reload. So we can apply that specifically while watching the database logs, while being ready with a rollback command, any of that stuff. So it allows us to be very careful. And then let's say the other thing is somebody's password changing. So we can blow that out. So we would do cap staging, Puppet apply for the rest of the environment. Usually we make it a practice to check for a clean nuke before you push, and then you push. So this kind of practice allows us to be selectively careful while still allowing us to target multiple boxes. So Git is sort of distributed by default. You do have to deal with your central repository to back it up and stuff. But so far, this has worked really well for us, just kind of the nature of Git being distributed. So I thought it would be fun to kind of put all this together and actually show you the real directory structure that we use to manage our environments. So this is it. This is the real deal. Warts and all. At the top, you'll see the config directory has a bunch of capistrano tasks, including our supply drop config, a version of what I showed you a second ago. The data centers include some variable farms that I'm going to talk about in our lessons learned section. That's where kind of base information about a location is stored at the kind of every node inherits from it. And you'll notice we also have top-level manifests and templates. These are from the days before modules. We still are moving everything into our new fancy modules directory. And so, yes, we have a lot of legacy code. Here be dragons, I think I put. Yes, because there are dragons there. Then we separate our nodes out into a directory per data center and then a file per class of box. So you'll have like app1 through app5 in that directory. And then our top level Puppet file is, yes, it is still called Puppet PP, not site PP. So this is just a great example of like when we started. Like I think it's a great, like in any technology, if you name the file after the technology that it is, like ruby.rb, python.py, it means that you have no idea what the hell you're doing. So we just haven't changed it because I think it's kind of cute. The other thing to mention about this particular directory here, the vendor directory, is because of the way supply drop works. Supply drop just rsyncing files out to to a location on the remote node. We can actually vendor Puppet and Factor and supply drop together. So we don't actually require Puppet to be installed as like a system gem on any of our servers. We just require Ruby. So this allows us to quickly upgrade Puppet. All we have to do is check in a new version, and it's going to get rsynced down. And all of the supply drop commands, they're able to reference kind of a nested Puppet gem. So that's kind of a little cool feature of supply drop as well. Is there anything else I wanted to say about this? I really want to get rid of those manifests and templates directories, let me tell you. Okay, but I'll talk actually a little bit more about those variable farms in the next section here. So, probably the most important part, right? Lessons learned. Where have we come in this space from not knowing what the hell to not knowing what the crap that we're doing? There's a couple of things that I think are really important that I've taken away or that we've taken away as a team. One, Puppet is a dangerous weapon. Like any sufficiently advanced technology, Puppet will allow you to shoot yourself in the foot repeatedly, and it will happily do it. It'll efficiently do it even. So it's up to you to know whether or not your foot's all bloody. So what do I mean by this? Well, here's a simple example. So this might be something that you'd see early on in our Puppet days. You got an app node, and there's one in QA and there's one in prod, and it's like, oh my god, we can just include users, and we have the same users on both boxes. This is awesome. Puppet's doing its job for us. And then we can get the Rails dependencies too. Same on both boxes, perfect. And it's like, okay, now we got to include Apache. Ooh, there's something that needs to change between these two environments. Okay, so we need 2 different host names. There's www and prod and QA an example. So wait, Puppet has something for this, right? It's templating. So we just need, we need to hook on something. Okay, what are we going to hook on? I know, we'll set a global variable. Wah, wah. Okay, so this is the major problem, right? A global variable. So the real problem with this is not the kind of stylistic problem. The problem is that it works, and it will work for you for as long as you need it to, until you need to get more complex. So I don't know, I don't even know if I can judge this, because this will actually do its job. But the problem is, you take this and then you expand it out to the complexities of all your environments, and you end up with a huge file with a bunch of variables, all of which hook on something way down in templates. And so maybe this particular example is okay if this is all you're doing, but that's what I mean, that Puppet will let you do this. It will actually let you do this kind of efficiently. but if you expand this out, you're going to end up with variable farms and basically kind of your truth spread across your environment. So the kind of standard way to do this is think about a type, right? What sort of type are we talking about here? It's kind of an Apache site. Maybe this would generate a vhost, and then you pass in your host name down. This is a super simple example, but so basically mind your abstractions. So there's a couple of different ways of talking about minding your abstractions that I think are important. So there are a couple of questions I think you should ask up front when you're trying to model something in Puppet. I think you'll probably hear a lot of different ways of talking about this, because I think there's a lot of sessions in this conference about like constructing Puppet types and Puppet classes. But these are a couple of things that I think about whenever I'm kind of starting on a new concept in Puppet. Is it 0 to 1 or 0 to n? So can a box have it or not have it, or can a box have more than one of them? That's going to lead you to a class or a defined type. Is it generic or unique? So is there basically, is it a concept that is generic to the world, or is it unique to your particular organization? So is that like an Apache site, or a Postgres database, or is it like a Braintree gateway app? Generally what we found is you can think about it as layers. So you have a layer of generic types that compose themselves into the types that are specific to your company. That way you can try and keep a layer that you can then share amongst your apps and amongst other people. And then what changes, right? So that's going to be your variables. So you're going to determine what's required, what's optional, maybe put in some sane defaults. So these are the sort of questions that go through our heads when we're modeling a new concept in Puppet. The other thing that we learned within the last year, and we are striving to do it, is to use that module pattern. Everything has a place, and there's a place for everything. It's wonderful. I will never write another line of Puppet that's not in a module. And then you can share them on the Forge. The Forge is like just coming into this renaissance of being able to have all of that. There's going to be a ton of sessions on that today. I think it's really awesome. So the module pattern is the way to go for sure. So another way of talking about these problems that we've come into is minding your scope, right? So what we had was a variable that was way up in the location being referenced way down in the template. And really what we found is that you really want to explicitly pass down your scope into Puppet, so you're mapping complexity at each layer. So you want your node to reference only things that are in the location. Things get a little muddy up there, but definitely you want your templates to only reference things that are coming from their specific class, their specific type. Once you start referencing variables elsewhere, that's when you get into a lot of trouble. So at base, what I think is important here is the concept of truth. I think it's truth in an ops sense. I'm sure you'll hear a lot about this today. But the truth being like the actual metadata that you are representing about your environment. This is an app node. This node has a Postgres database named foo. This node has an IP address of 1234. The truth in your environment is, I think, the most crucial thing that you need to think about from the very beginning. And Puppet will gladly scatter your truth everywhere. And that's basically what we did. We've been able to lean on our practices to keep our production environment sane and safe. But that doesn't mean that, but now we're at the point where we'd like to get better knowledge about our overall environment, and we found that our truth is scattered across our entire Puppet repository, so that directory structure that you saw. So sort of my thesis statement, and this is sort of where we're at now. We don't have good answers to this question. But the thesis that I'm working with is Puppet does not manage truth, the core Puppet tool I'm talking about here. It maps truth to complexity. Puppet provides hooks for you for it to talk to other places that manage truth, things like facts and external node classifiers, and that's the stuff that I'm here at PuppetConf to learn about. But so we've gotten pretty far with Puppet, but this is the question that we're asking right now. How do we manage truth? We're looking at building our own configuration database. We're looking at a bunch of tools that are going to be talked about in this conference, but we've managed to get pretty far. Just learning what we've learned and knowing what we know, but we have a long way to go. And so I wish that I could be standing up here being like, this is exactly how we manage truth, but I don't know the answer. I'm just in the trenches. So thank you very much. I'm happy to take any questions.
Do you abstract out application layer from the actual drop down of your apps and versions? If you have a different orchestrator for that? I mean, do you separate the layers, or do you manage all that from within Puppet?
So we use you're talking about application deployment versus like package management and stuff like that. So we use Puppet for all the package management stuff. We have a full capistrano setup for our application layer deployment. So what we have is Puppet will set up all the directory structure that capistrano expects, but our like app deploy operations are capistrano operations. So we'll do a cap deploy, and that'll put the code out there.
How do you do report?
So how big is your environment in terms of nodes and how dynamic it is?
Sure. Yeah. So that's one of the reasons that we've been able to get away with this kind of masterless, human-oriented setup is because our environment is relatively static. It's growing at the pace that we develop features and get new clients. So we basically have 3 to 4 environments, each of which with more than 50 but less than 100 nodes. So we're really kind of pushing ourselves at the seam of this way of doing things. It's worked well for us so far, but because we've scattered the truth around, now we're seeing the problems at scale, which is like, we want to deal with these boxes in groups, not just individually. But so far it's been able to really help us be very intentional about the work that we're doing in production.
How do you reporting on how do you know the Puppet apply succeeded or not when you do the push?
Yeah, so the Puppet, the reason that you know that the Puppet apply succeeded is because there is a person there applying it. So you get it out, you get the information out right away. And so that's sort of the way that we've chosen to manage our infrastructure. So there is somebody who's running the Nuke, looking at it, and then running the apply and looking at it. So again, like once you're at a much larger scale than we're at, that's maybe not viable. But for us, where we want to be incredibly careful, incredibly secure, and be incredibly sure that we're not going to screw anything up, it's worked well.
I heard you mention that you're creating your own database for the facts and information. Have you looked at PuppetDB?
I am looking at PuppetDB as we speak. Yeah.
Definitely take care of that.
Mm-hmm. Yeah, it's interesting. One of the questions about a lot of these tools are you willing to go back to a Puppet master scenario? Because a lot of the tools are oriented around that. So it's hard when you already have all these practices that you like built up around the distributed nature of masterless. But yes, definitely going to be looking at that.
Question: are you using the mCollective component at all in your environment?
We're not. So capistrano sort of fills that role for us. It was just a tool that we knew. I think that from what I know of mCollective, I've actually been meaning to see if we could kind of flip over to mCollective as like the distributed command structure under supply drop, or maybe have it sort of be optional. But that's all that we would be using it for.
Because if you go to a master-slave environment, you could use mCollective, and then a central point of logging for the service that you could go back and peruse and see for errors before you actually do a flag. So that's an idea you may want to ponder.
Sure. Appreciate it.
Good stuff.
All right, guys. Thanks for sweating it out with me.